So I call this type 0 because I have type 1, 2, and 3 that we're gonna do. Type 0 I have to like insert into my notes, and that's just where the points are given. Types 1, 2, and 3, we're gonna come up with the points, all right? Using the axis of symmetry, using that kind of stuff. So we came up with the equation. We typed this into L1 and L2, keystrokes equation right there. We use y and x, but we know that, right, it's time and height, right? Y-intercept is, in this case, our initial height. We came up with how long it would take for the stunt, right? Knowing that it starts at the initial height and it stops when you get back to that initial height. We figured that out. So that was an interesting one. We don't have y2 is equal to 0, right? We don't have x-intercepts. So watch for that, right? There are no x-intercepts here. Because normally would ask you like how long did it stay in the air or that kind of stuff. In this case, we're always in the air, right? Like we're not really touching the ground. D, what was the plane's lowest height? We focused on that vertex, right? And it takes 9.8 seconds to reach that low point, and it's at this height that we're interested in, so we state that, right? Make sure you state exactly, make sure you answer the question. And now we're going to graph. So when you graph, you can use these points here if you'd like. Some students just take these and plot them, but you can just stick with how I showed you, right? I showed you vertex, intercept, that kind of stuff, right? So let's graph this real quick. You may have done this already, so you can just enjoy the ride. Okay, so that'll be time in seconds, height and feet, right? So just make sure both elements are there. It's no longer x and y. This has a context surrounding it. It's very important that you understand the difference. If this had just been a quadratic function, no word problem attached to it, the graph encompasses all 4 quadrants, right? But right now we understand time cannot be negative, and then we're staying up in terms of height and the positives. So we know that's all in quadrant 1. So 1080, I need to fit that in. So let's see, 200, 400, 600, 800, 1000, right? So if I go up by 200s, that works for me. And I'm going to make sure I mark, right? I'm talking about these specific points here. 800, 1000, 1200, right? There we go. That's a good scale. And time, I know this whole thing takes about 20 seconds, right? 19.6, right? So let's see here. 5, 10, 15, 20. That's beautiful, right? 5, 10, 15, 20. Let's just stick with that scale of 5 seconds. And now you start plotting. 1000, this would be 1100 right here. So 1080 is just shy of that. That would be my starting point. At 19.6, that's about in the 20 mark here, I come back to that height. So I'm just going to be a little bit in like that. So that's that. And then the vertex, right? You do have the vertex, you have the intercept, and you found a third point here. This is always a go-to. You can just make a line, y2 is equal to the initial height, to find the cousin on the other side of the axis of symmetry, right? So 9.8 is about here where the 10 is. I'm going to use that as a reference. And I'm going to go at 179. This would be 100, 150, 179 is right about there. Okay. There we go. And of course, your graph may look a little different if you used a different scale, but that's okay. There you go. That's my equation. I've got the 3 main points on there, and you're good to go. I know that on the provincial exam, it has said in the past, use the points given up here. Plot those. They want those to show up. If they do say that, then go with it. Okay, go with what they're telling you. Or if I put it on a test, I tell you, hey, use those points. Just go with them. Okay, so we have our graph. That's good. So this would be E, question E. F, state the domain and range in both formats. How I have to be careful with space here. Let's, yeah, just right here would be fine. So F is the domain and range. We're going to do that in both formats. So a graph is great for that, right? Domain talks about time, and it would be 0 times 0 to time 19.6, right? That's when the story ends. Or you could use this format, right? And then for range, you can you use the lowest y value is reached here, right, at the y, at the vertex, the y value of the vertex. So that would be 179.63. You're going to do that on the AC today as well, this kind of stuff. And then the highest point based on this scenario is 1080, right? Or 179.63, right? Y 1080. There's your domain and range. Very important. If this had not been a word problem, domain would have been all real numbers. Right? This thing keeps on expanding indefinitely to the left and to the right, so all x values. But it's a word problem, so I need to kind of just see what's happening here. It's restricting time. And you also have a restriction on your height. Because of the time restriction, right, we know that it ends when you reach the initial height. We are restricted to basically whatever you see there, whatever your graph is showing you. Okay. And then G. I think I'm going to do G up here in this area right here. G. How long was the plane at or above, very careful here, at or above 800 feet? So we let, in this scenario, we use the height, and we know that it's the y value. So we're going to go second, trace 5 for that one. So let's go ahead and do that. Y2 is 800. Hit graph. And so we're interested in the first scenario and the second scenario. So you have to be very careful here. Watch what I'm about to do. I'm first going to pick those 2 points. Let's go get those 2 coordinates. Second trace 5. I'm going to get the first one. Enter, enter, enter. And I'm going to give you a little sketch here for this. So just to have an idea what's happening, right? So we do this. This is our 800 mark. So the first x value, x1, is 1.6653. I know it's hard to see, okay? But it's 1.6653. Write that down. The second instance is what we call the x2. Let's go ahead and find that second trace 5. I'm going to jump to the red line, cut across, enter, enter, enter. That's 17. Let's write that down. 17.9346. Now I'm going to get rid of the calculator and zoom into that so you can see it better. All right. We're at or above, right? If you subtract these values, you're always going to get what I call like the hill or the valley. If you were to subtract these two numbers, you would actually find the time at or below right now. That's what you would find. But we're interested in above. Does that make sense? So let me just have some scrap paper to illustrate the point here. So if your parabola looks like this and you find your line like that, if you subtract these two, you're actually going to find the time spent here at the hill, right? At the top of the hill. If your parabola looks like this and you find both of these intersections and you subtract these x values, you're going to find the time spent here, right? So subtracting always gives you either the hill or time spent here at the valley, right? So you got to keep that in mind. So what we're going to do is this time. I'm going to be it's going to be crammed here. Time above, or sorry, below, I'm going to say, is going to be 17.93 ... minus 1.665, right? Time below is this. I'm going to call t below. Let's subtract that. And I got 16.2693. And I'm going to use a highlighter for that. This that you just found is representing the time spent there. But you want above. So how do we do that part? Time above, we go total time that this plane performed the stunt for, which is 19.6 seconds, 19.60, minus this time here, 16.2693. So time above, if you subtract these, because I'm not done answering yet, so I keep my answer to 4 decimals, right? And so this would be 3.33 seconds. And I'm going to use a different color to illustrate. Right? So these are rare that something points up. It's rare, but it does happen. So I need you to be ready for it. So when you subtract, you're finding the valley or the hill, the top of the hill, for sure. So you always got to ask yourself, what is the question asking? Do I need that extra step where I actually find everything else, like the wings, so to speak? Right, the wings or the ends? Or am I interested in the valley itself, or sometimes the top of the hill? So just read the question carefully. I'm gonna just box this in. I don't know, my brain doesn't work very well when I see a whole bunch of stuff just scattered all over the place. So that would be G on its own, right? Kind of compartment on its own. So I'm actually going to do that with everything, or maybe as much as I can. It's like here's B, C is right here. Whatever works for you. And this concludes page 49. Okay, so I kind of pretty beefy example, lots of stuff happening here.